Hello, good afternoon and welcome to the start of this UK Hydrogen Week here at Brunel University. This is the start of a 5-episode webinar series titled Thinking Differently in Hydrogen, hosted by me, Alexander Reep, Brunel's Royal Society Entrepreneur in Residence. Each day we'll be having a presentation from a Brunel expert on a specific topic, followed by a talk from an SME who are developing technology to help support the UK's hydrogen economy. A few housekeeping tips just to mention before we start. Firstly, these webinars will all be recorded, so if this is an issue, please leave now. And then after the talks, we'll also be having a Q&A session. So please do type questions in using the chat function on Zoom, and we will sort of pass those to the speakers afterwards. If you can also please keep yourself muted during the talks. You will, if you want to be able to actually ask your question directly to the speakers, then that's absolutely fine during the Q&A session. But until then, please keep it muted just to make things easier. So with that out of the way, yes, let's get going. So today's topic is hydrogen living labs. Now, over the past few years, as I'm sure everyone has been hearing, the government has really been highlighting the need for a UK hydrogen economy. Last year, the plans were increased with the target for hydrogen production to be doubled by 2030 from 5 gigawatts to 10 gigawatts, with at least half of this coming from green hydrogen technologies. So to hit these targets, the hydrogen sector has been very quickly innovating new technologies all across the supply chain, from new production technologies, new storage vessels, new ways of transport, and of course, new end uses. But one area that we have seen that has been slowing down this growth is the need for facilities that enable mid-TRL to high TRL testing. This is one of the things that Brunel University has been looking into, and it's the creation of a hydrogen living lab that will allow independent testing for these kind of technologies at larger than bench scale and before they reach the market. So today we're joined by Dr. Jen Baxter, who's been working with the Brunel hydrogen team to develop these plans. Jen is the Deputy Chair of the National Infrastructure Commission Wales, a board member of Industry Wales and Newport City Homes. In her day job, Jen works as an independent engineering advisor on green hydrogen and wider energy and sustainability systems. Jen was previously the engineering director for Protein Green Solutions and chief engineer at the Institute of Mechanical Engineers. Jen is an expert engineer advising the media and government, covering all mechanical engineering subjects, and specialises in energy, transport and the environment.
So before I begin, I'll just say that if you do have questions that you want to ask, I think we'll try and have a little bit of a Q&A session right at the end of this presentation, because what I'm going to talk through a little bit today is some bits of information that you probably are aware of and others that perhaps you are not, in the way in which an H2 living lab and the role of demonstration can actually support innovation systems and the delivery and commercialization of our hydrogen technologies. So as Alex has mentioned, we're talking a bit here about the work that Brunel is doing in terms of a practical and enabling solution to understand how we actually use hydrogen. There is some really good understanding of how to produce hydrogen, but what tends to happen is there's a little bit of a drop off in the how do we go from the production to the end use, who can use it, where to use it and why to use it. We often hear in the news that it's a good solution for almost everything from electricity to gas to oil replacement. And although in theory, you can use hydrogen in all those different ways, it's actually perhaps not the best or most useful way of communicating hydrogen for a future hydrogen economy, whether we're talking about for energy use or for greening the feedstocks within our industries. So I'm Dr. Jen Baxter, and this is a quick route through innovation systems and delivering hydrogen through demonstration. So I'm hoping these slides are moving. They're a little bit slow at my end, but I'm hoping that they're all going through. Hopefully Alex will give me the thumbs up to tell me that that's all right. Yeah, great. So one of the things that I did the other day was I went back and I had a look at the hydrogen headlines. So I wrote my PhD, I finished it about 10 years ago, on hydrogen production from waste. And since then, I've been working in advocating and perhaps communicating the ways in which hydrogen can best be used. And what I found quite interesting, I haven't done this for a while, was looking at the hydrogen headlines, was the number of different types of tests that are going on, the technologies we're looking at are actually reducing. Now that might be seen as a good thing, but it also may mean that what is actually happening is that we don't have the facilities and the opportunities to test some of the technologies we want to use. So you'll see here from the headlines, we've actually got two around aviation. So there's one looking at the MTU Series 400 L64 engine from Rolls-Royce, where they've been testing that using 100% hydrogen fuel. And also the Hy2Fly Eyes Summer Flight Test campaign, which is looking at liquid hydrogen fuel cells. I spent a couple of years working on the future flight programs for hydrogen. And it is really interesting the way in which this is now being talked about, because whether we look at it from the point of view of direct hydrogen use or synthetic aviation fuels, which both need hydrogen use, there is a bit of a challenge in how do we get from the production point to the point where we can use it. And some of that is about the amount of hydrogen and also how you test it along the way and how you store it. The other area that we're seeing a lot of work in, and JCB have been in the hydrogen space for a long time, is looking at machinery, whether it's JCB diggers or whether it's mining machinery, that often works in areas that are quite challenging to get electricity to. So hydrogen offers another solution. And then SoCal Gas, along with other companies in the UK, are looking at hydrogen for clean energy, particularly in terms of heating. Now that could be heating through the natural gas grid system, or it could be heating through fuel cells. So there are different elements of the way that hydrogen is used that need to be tested. And we don't really have those test areas for it. There's a little table just on the right-hand side here that just identifies 3 main demonstration sites where potentially you could test elements of the hydrogen supply system. So the EMEC, which is up on Orkney, that actually has quite a large number of testing facilities. But the challenge with that is that it's on Orkney, which means that it's maybe too far out of the way for a lot of companies who may want to test, or even for universities to be involved with some of the work that they do. Then the University of Sheffield has quite a good centre, but they have a good history around working with the AMRC, which is the Advanced Manufacturing Research Centre as well. So there's a lot happening at Sheffield. And then Imperial College has a Future Labs demonstrator, which focuses a lot on the way in which different energy systems interact with each other. One area that we find that there's a big gap in is understanding how we manage control systems and switchgear and how those different parts of the energy system fit together. So I wanted to talk about technological innovation systems, and I've put this slide up, and it's actually because I don't like TRL levels, but they do explain the system very well. So when we talk about demonstration and we talk about some of the challenges that go from research to commercialization of our ideas on our research, we know that the university works primarily in TRLs 1 to 3 and maybe some of 4 and 5. But there is a real challenge in 5, 6 and 7, because what happens is we get to a point where we've got a really good idea, a really good product idea, we've prototyped it, but we haven't got anywhere to test it, or a company has approached the university and said, you know, I need some hydrogen, but I can't get it. I need to understand how my solar interacts with my electrolyzer, but I have nowhere to do this. And I don't want to make that investment until I understand that the technology has been validated. So this is where we get a failure. And the reason that I really wanted to share the TRL levels with you is that this is how the government talks about innovation. It's often how the research councils and Innovate UK provide funding. They say you must be within this TRL set. But the problem with this is it demonstrates it as a linear process. And the thing about innovation is the one thing it isn't is linear. So on the next slide, which I'm not going to spend too long on because it's quite dense, and I'll pull a few bits out when we talk a little bit more about commercialization. It shows a little bit more what a technology, how to create a technology that can really be commercialized and what the innovation system looks like. So it's always very difficult to get this matrix onto a slide, so I've done my best here. But what this really shows you, we don't need to go into too much detail, is that every element of the innovation system has some kind of effect or impact on another part of it. It isn't the case that you can just go along saying, oh, I've thought of something, it's a great idea, I've made a prototype, I've tested it, and now I'm going to sell it. It just doesn't work like that. We see that there are ways in which we need to continue to influence government, we need financial models, we need regulation, and all of these form part of the innovation system. And what we want to do at Brunel is to kind of create an environment where we can start to understand what are those parts that are missing from the system and how do we build that into the demonstration process. So I'm going to leave this here, and I think that because it's recorded and I'm sure the slides will be available, you can kind of read in more detail what some of these different areas are. So I'm going to talk about the Valley of Death, and I'm sure everybody's heard about the Valley of Death. And I apologize, this slide has a slight error on it, but I've borrowed this this image because it just demonstrates it really well. We can see where the investment is on one side and how government and universities put money in, they do the research, everything happens and it's all really great. And we've got some good ideas and some good policy. And then there's this, then we want the private sector to pick it up and run with it. But there's this gap where everything fails. And the valley of death is not something that anyone's ever really managed to find a solution to. But what we do know is that this is the space where demonstration can support delivery. So I'm going to move on to talk a little bit about that now. So what we've got here is understanding the sort of commercialization side of demonstrations. So the ultimate goal is we use demonstration through prototyping and technology advancement to commercialize our products. And that is the end result. We see spin-out companies that come from various universities all the time. We see successful commercialization of technologies that are accidentally developed as part of another process. So things like, you know, the digital camera is a really good example of that, where it was developed in the 70s, but nobody knew what to do with it because it really needed the internet to be developed to be beneficial. So there are accidental commercialization that happens later on. But the way that demonstration works and what it allows companies to do is this entrepreneurial experimentation. So we build relationships and collaboration with companies, and we'll hear from an SME after I've spoken to explain how that can support them. But what we can see from that is the following things: that commercial experiments promote competition and can lead to new markets. So companies get involved and we share that information and we talk about it. And then they start to think, well, hang on a minute, if they're doing this, could we also do that? Is there a way that we can test our products? And can we then have key commercial examples that influence government policy and incentives? So where something is very successful and where a company is, one, able to experiment and then to implement in their own business, that often leads to the government actually making specific policy that will allow more people to do that. Then businesses choose to invest and it shows confidence in the research market, and the universities can pick up more money to do more research to continue to improve. So that's your feedback loop, just one of them to give you an example. We then develop niche markets, and that encourages more entrepreneurs to invest, and technology pilot schemes begin to pop up everywhere. And when we talk about hydrogen at the moment, we are seeing people trying to do this, but where the challenge is there's a lot of good ideas. There's a lot of money in feasibility studies, but what doesn't happen is that turning into technology deliverables. And so then new niche markets can create jobs and opportunities. And fundamentally, what happens in demonstration is learning by doing and increasing competence in an area where we particularly need it and where we don't understand why we're failing. So this is where, very specifically, demonstration supports commercialization. And so when we talk a little bit, sorry, my slides are a little slow here. I'm just going to try again. One of the photographs is missing. It'll probably make an appearance in a moment, but I may also be stuck. So we'll see what happens. So what we're trying to do here is to look and work in that messy middle application. So we know how to produce hydrogen. There are different ways of doing it. Admittedly, none of the green ways of producing hydrogen are really being done. So there is still some space there to understand why that's not happening and what the challenges or the skills that are missing may be. So within Brunel, we have the opportunity to bring together engineering, digital skills, social sciences, business skills. And that can actually mean that we start to create a much more rounded technological system that will deliver good opportunities for businesses. Tried a different button on the computer and I'm now able to move forward. So there's a lot of work that's been done at Brunel already to understand what possible education can be done alongside this, what type of buildings could we have, what sort of labs do we want. So just to talk through some of the demonstrator activities that we hope that we'll be able to put into place and how they actually fit within Brunel's activities. When we talk about research, that is to identify missing links and challenges, to start to think about how do we fill holes in the industry where we can bring together local communities, we can stress test materials, we can understand what the challenges are or look at the market development, we can test equipment or create equipment, and we can support proposals both in the social and physical sciences that will allow hydrogen developments to move more quickly. And it also allows us to think about what are those competencies that we are missing, where are we seeing that there's a problem in terms of what happens in the workforce. And so when we get to demonstration, the labs and research collaboration space, electrolyzers, storage, solar are physical parts of the demonstration. But what actually happens within that is that we're able to say, do you know what we really need? We need to understand what the safety issues are around delivering these small electrolyzers across lots of businesses. Or we need to understand what the financial model is that allows us to do compression more effectively. Or there are so many different elements and skills that are built into this, and they can all be tested, and learning by doing can be done through demonstration. And then that feeds us into the commercialization, which is developing the latest knowledge on sector delivery technologies and relationships. And fundamentally, a lot of this is about decarbonisation. So what is it that is happening within hydrogen that is either stalling progress to green the existing hydrogen markets or to develop new hydrogen markets? And how do we support test beds that will allow those deliverables to be done more rapidly? And then finally, Brunel is an education institution. So what we want to make sure is that those people going into the workforce are highly skilled, are competent, and are able to support companies almost immediately with understanding the engineering, the finance, the marketing, the communications, the community and stakeholder relationships, all associated with new energy systems. And so that's really how we see that kind of filling back into the degree programs, to the researchers' activities, and also potentially having companies that are able to come onto the demonstrator, look at the activities, use the facilities, and actually learn those skills themselves. So there are many ways in which these then feed round to develop regulation, to develop new financial models, new technologies, to understand what materials work best, and ultimately perform the activities that we would expect a university to do. So that's where I'm going to leave it, because I do want people to ask questions. And if they're very specifically about particular hydrogen technologies, I will do my best. But if they're also about how do we make sure that we can build that collaboration, we'll try and kind of go through some of that so that people can work out how to work with local companies as well. So Alex, I'll hand it back to you.
Wonderful, thanks very much, Jen. So yes, if anyone's got any questions, please do, as I said, put it in the chat, or we'll also save some time later on to ask them in person. So next, I want to introduce Niall Haughian, CEO of Hywaves. Niall is co-founder of 3 tech startups, including Hywaves, which is a Cranfield University-based power electronics company. Hywaves is developing technology that enables direct connection from solar parks to electrolyzers to help reduce capex and opex associated with solar to hydrogen plants. Niall, the floor is yours.
Let me just share my screen. Hope you guys can see it.
Yeah, we got it.
I just want to just pick up on something that Jennifer said. I think one of the main problems is that hydrogen's got a terrible, terrible reputation, truly awful reputation. And the minute you speak to anyone about hydrogen, the fear of God takes over. And universities deal with sometimes very dangerous substances, molecules, you name it, gases that are just as dangerous, if not more dangerous, than hydrogen. But managers on site are very, very reluctant. So there's also needs to be a bit of a mindset change at universities and research organizations to accommodate hydrogen production. So it's very easy to actually produce hydrogen at a small scale. It's not overly dangerous. But talking about the value of debt, well, the value of debt is also the infrastructure in research organizations, including Brunel, that they don't have the facilities in place that actually can produce hydrogen, store the hydrogen safely without causing alarms at senior decision makers. So I think the universities need to actually step up in a big way to be able to accommodate the hydrogen production and overall. But one thing I would say about it is there isn't enough engineers. There's definitely not enough engineers coming out of universities. And for hydrogen production, you need a lot of engineers and scientists. You got the electrochemical engineers, electronic engineers come to my mind, and they're so sought after, and they're just, because of all of these restrictions and EU, etc. It's a big bottleneck for actually getting a hydrogen technology company off the ground. So there's multiple issues here that universities need to step up on, and I hope Brunel actually is listening. So value debt, a lot of it's down to the economist in me would think it's down to money. In actual fact, it's a lot of factors and resources, and getting to the next technological milestone is vital, and it's quite hard. And I've been reaching out to numerous universities to actually get to the next stage, and it's been exceptionally hard. But I'll just give a little bit overview of Hywaves, and so we can go down and get then onto the Q&A session. So Hywaves is our focus is on producing locally produced hydrogen, and one of the reasons for it is because, as I stated already, I'm an economist, and oddly enough, I'm also a critic of hydrogen production. Hydrogen, it's a bubble, but there's a lot of need for hydrogen, but it is in its own place. And the idea of transporting hydrogen from places like Chile, South Africa, and providing hydrogen for places like Germany and Japan, I think the economics of that screams no way. So there's so much factors in there. The cost of producing green hydrogen is already excessively high. The idea of then liquefying it, transporting it, it's a non-starter in my opinion. So our focus is actually producing hydrogen locally and providing it to nearby industry. And hopefully the hydrogen sector can focus on migrating the dirty hydrogen, gray hydrogen, and less dirty but still dirty blue hydrogen to green hydrogen. So migrate it as quickly as possible, so that it's actually we're producing hydrogen from clean energy sources such as wind and solar. So where's the main drivers here? I've got a picture there of steel, and that's what we should focus on. Hard to abate industries like steel, fertilizer, cement. The idea of hydrogen in cars. Only today I've seen this wonderful video of a guy who drove 600 kilometers on a hydrogen powered car. Unbelievably stupid. It's really absolutely stupid that people are still focusing on hydrogen for cars. It's never going to get off the ground. Batteries that keep on getting getting cheaper by the day, while hydrogen is always going to be very hard to get off the ground because the infrastructure required is immense. But for heavy industry, we have to move away from it. We have to move away from natural gas and such, because it is incredibly polluting. Fertilizer, cement. I mean, what percentage is that up to? 15+% of the world's CO2 come from them. So, and then there's the big push in places like Germany, who have been overly dependent on Russian gas, and now they're trying to figure out how the hell do we move away from that. Germany and places like this have got an abundance of wind in the north, an abundance of solar in the south, and it is ideal for these type of situations where you need these to overcome days where it's a gray and a still day. So hydrogen can fill the void for that, but again, the main driver should be decarbonize heavy industry. Now, what most folks don't know is there's lots and lots of solar farm developers and wind developers that actually want to get into the hydrogen world. they think there's going to be a massive market, and they are right. Migrating hydrogen from gray to green is going to be a huge market by the end of the decade. But most of these folks, they've got huge bottlenecks. They know how to build solar parks and wind parks, but grid connection is next to impossible. Grid is such a major obstacle in electrifying our heating, our transport, but also to producing hydrogen. So our focus is almost to provide solar and wind developers off-grid solutions to produce hydrogen. So build a solar park, build a wind farm, specifically for one thing only, hydrogen production. And that's where we're coming in. So if you have a solar park and it's exceptionally, and if it's very expensive to actually design solar to hydrogen plants, there's a lot of inefficiencies. And what is going on right now, the guys who are doing pilots, the likes of BP, Shell, they're in little silos. And one silo is the solar park. So for example, BP, they've got Lightsource manages their solar development. They're used to building solar parks for the grid, and that's their bread and butter. And they don't really realize that you can optimize this to a solar farm to actually produce hydrogen directly from solar. And because at the end of the day, an electrolyzer requires DC energy. And so they're building the solar park as if it was providing it for energy for the grid. And that has a lot of wiring, power electronics, especially the PV inverter. And what we're doing, and once you've converted it, or an inverter is many things, but the primary reason you have an inverter is to convert DC energy into AC energy. But once you've got it in AC energy, then you have to convert it back again with transformers and rectifiers, and they are exceptionally expensive pieces of kit, and you got losses along the way. So what we're developing is a solution that you build a solar park for one reason, like I said, to produce hydrogen, and we're developing electronics that goes into the electrolyzer that enables it to be able to handle the variable input. Electrolyzers, a lot of electrolyzers, which is more the alkaline, for example, electrolyzers cannot handle variable input in any way. So what we're developing is a solution to enable variable input, which is a major problem because especially in a country like UK, good chunks of the likes of January and February, there's going to be very little production of solar output. But going back to what Jennifer talked about, we've developed this technology so we've developed our technology on a 1 kilowatt. Our value of debt is actually demonstrating this in a more, if you look at a solar park, you see what we call strings of solar parks, solar panels, and they could be 20 kilowatts up to multiples of that. And what we're having a very big problem is actually demonstrating the technology on a more commercial scale. So we demonstrated on 1 kilowatt, which is 4 panels, and now we want to actually take it in the next stage. But we have multiple obstacles at research organizations to actually take our technology to the next stage. And time is money. So I've hired quality people, but actually overcoming or providing an ability for startup companies like us to demonstrate, move up the technology readiness level and demonstrate on a more commercial scale has been excessively hard, and something that I hadn't quite considered it was going to be that hard. And that's slowing down is slowing down us in multiple ways, and the time is leading to me needing to raise more money, and also it's preventing engagement with end customers such as energy companies and electrolyzer companies. So it's a rather frustrating situation, but I do think it can be overcome. But the education research organizations and universities need to really step up to enable green hydrogen to get off the ground, let alone financing.